Hello, so today we are going to be looking at lesson 3.6, and in this lesson we are going to be looking at direct variation, and we're going to be learning how to write direct variation equation as well as solve application problems that have direct variation. And before I start, I just want to make note that the homework tonight is not from the textbook. This homework is a separate worksheet. Please check Blackboard. The worksheet is there. If you have trouble finding it, please let me know. This homework is going to be due next Monday at 9:30 a.m. So let me know if you have any questions or have trouble finding this worksheet. Okay, so direct variation. So the first thing is, it says an exchange rate is a number that it describes how much of one currency you can trade for another currency. So for example, the United States, right, our dollar is not equivalent to $1 Canadian. $1 US is equivalent to $1.20 of Canadian dollars. So when we travel into different countries, that's why you have to make exchange rates. So this asks you to find the exchange rate for US currency to rubles. So I did this for you. $1 US is equivalent to 58.4 rubles. How would you write this as a conversion factor with US dollars in the denominator? So we want US dollars on the bottom. So 58.4 rubles per $1. Okay. Now using this rate, we are going to complete this table. So how much would 10 US dollars be? Well, you have to multiply 58.4 by 10. You do 58.4 times 20. 58.4 times 30, and so on. Okay, draw a graph based on your table. Make sure to make a scale on each axis. Okay, so to make this graph, first thing is that remember rate is the change in Y over change in X. So Y is going to be my rubles, X is going to be US dollars. Okay, so I'm going to count here. There was enough room where I was able to count by fives. I didn't write fives, I skipped it, but just note that's 5, 10, 15, 20, 25, 30, and so on. And make sure, see how I labeled it with dollars? It's extremely important that you label your axes, because if you don't label your axes, then what do those numbers mean? We'll have no idea. Okay, and then I also noticed that on the rubles, if you look, we have to go pretty much to 3,000. So you have to figure out what are you going to count by to get to 3,000. One way you can do this is you can say how many lines are there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then do 3,000 divided by 16, because that's where we have to get. And that gives you an answer of 187.5. Well, I'm not going to suggest to count by 187.5, but think about what number is really close to 187.5. And that would be 200, which is why I counted by 200. So 200, 400, 600, 800, 1,000, and so forth. And again, I labeled it rubles. And then I just took these points and I'm going to plot them on the graph. I just want to note that the points, remember it's estimate, because 584 is somewhere between, remember this is 600, so it's going to be closer to 600 than it is 400, but it's not going to be perfect. So just make sure you get it as close as you can. And then other note is that we need to have this arrow. And think about, why do you need to have that arrow? Well, can't we have more than $50, right? You can go on for infinity for dollars, just like you can for rubles. So the arrow signifies that it's going to go on forever. All right, so question 5 down here says find the slope of the line that you graphed. What does this represent? Again, remember when you find the slope, you have to pick any 2 points. It does not matter which 2 points. These are the 2 points that I picked down here. And remember, it's a change in Y over the change in X. So 584, subtract 0, over 10, take away 0. And that gives you 584 divided by 10, which is 58.4. What does it mean? That the number of rubles that correspond to $1. So 58.4 rubles correspond to $1. And you might notice that this is the same exact number we got earlier, because we wrote the rate earlier and the unit rate is the same as slope. All right, so now let's take this information and write an equation. So we know that the slope is 58.4, right? We just figured that out. And we know that the y-intercept is 0 because that's where the graph starts. So that means that the equation is going to be y is equal to 58.4x plus 0. We do not need to write plus 0, so it's just this. 58.4 rubles times the number of US dollars will give us how much we have in total. Okay, x is the input, y is the output. So if I wanted to convert $2.15, right, you would do $2.15 times 58.4 is going to be the equivalent of 125.56 rubles. All right, so basically, however many US dollars we have, we're going to multiply that by the number of rubles, which will tell us how many rubles you would have to share. Question 8, we're going to skip because we don't have graphing calculators. All right, so how many rubles do you think you get if you exchange $0? Well, if you don't give any money, then you're not going to get any money back. So it would be 0. Question 10, if you double the number of dollars you're exchanging, what would happen to the number of rubles? Well, it would also double, right? Because everything is directly proportional. And if you look here, if you go to 10 and 20, 1168 is double 584, just like 20 is double 10. Okay, and then 11, if you tripled the number of dollars, what would happen to the number of rubles? It would also triple. Okay, if you look at the table for the numbers 10 and 30, you would see that they triple. Question number 12, if you cut the number of dollars you were exchanging in half, what would happen? Well, they would also be cut in half. Okay, and this is something we call direct variation, okay, because they vary proportionally. They both go up at the exact same rate. And we're going to use the equation y is equal to kx for any direct variation problems. So anytime you have something that the number, they're going to vary directly, and if it doubles, then the other one doubles. And if one triples and the other one triples, and so forth, then that's a direct variation. And k is some real number, and that's going to be our constant of variation. All right, so let's look a little bit more at this. So here is the direct variation examples. This is something that you need to know. Again, we have the equation y equals kx. Here's an example. Y is equal to 3x. So just remember, 3 would be our slope, and that is also going to be our constant of variation. Something to point out, okay? Here, 1 times 2 is 2. 3 times 2 is 6. If I want to go 9, 3 times 3 is 9, and 1 times 3 is 9. So I can multiply both sides by the same, and it takes you to this correct number. That's direct variation. I put an important note here. Always has a y-intercept of 0. Notice your graph, it crosses at the origin, it crosses at 0. Okay, so that's just something important to think about. And also note that I mentioned earlier, k is the constant of variation. It says it right here, constant of variation is k. And that's basically saying, what is it changing by? So k is the same thing as your slope. All right, so everybody should go ahead and try to work on the group work by yourself, see how you do. And when you finish, check the next video so you can see how you did. And please let me know if you have any questions. Just a reminder, your homework is not in the textbook. It is an extra homework sheet that is posted on Blackboard.